In this video, we are going to find real numbers a, b, c, d, and e between -2 and 2 such that the sum equals 0, the sum of cubes also equals 0, but the sum of powers of 5 equals to 10. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. There is an unusual trick that can help solve this problem, and that is trigonometry. Precisely, we can let each variable to be equal to 2 times cosine of some angle. Let's say a equals 2 times cos big A, and I'm going to do similar things on the other unknowns. B equals 2 cos big B, C equals 2 cos C, etc. Now to proceed, I'm going to consider cos of 5a when the angle is multiplied by 5. And by some algebra, which I'm going to skip in this video, is that it's actually equal to, writing that in terms of cosine, 16 times cos a all to the power 5 minus 20 times cos a all cubed, and then plus 5 cos a. Then the trick is that we can notice if I add up these expressions, cos 5a minus 1, cos 5b minus 1, cos 5c minus 1, etc. Say if I write this as theta, adding them up with theta equals to either a, b, c, d, or e, then because by nature, by definition, cosine of any angle must be smaller than 1, or smaller than or equal to 1, is at most 1. So if I add them up, the sum must be non-positive. It can't be positive, it's at most 0, and most of the time negative. But for this sum, we're actually adding 16 times cos theta all to the power 5 minus 20, I should write theta here, minus 20 cos theta all to the power 3 plus 5 cos theta. And we know that these are actually just powers of the unknowns we have in our equations. So translating the sum of powers in terms of cosine, for example, for the third equation, is actually equivalent to saying that 2 to the power 5 times the sum of the fifth powers of the cosines is equal to 10. And similarly, I can say 2 cubed times the sum of the cubes of the cosines is equal to 0. And also for the sum as well. Now back to the summation below. From this we know that I can split the sum term by term like this. Of course, do not forget the minus 1 at the end. And for this minus 1, we're actually subtracting the outcome of all the summations by 5, because there are 5 angles altogether. So simplifying, we know that the first sum on the fifth powers is equal to 16 times 10 over 32 minus 20 times 0 plus 5 times 0, and then finally minus 5. And somehow is equal to 0. So we've established an inequality, but for the other side, somehow it's also 0. So that means for the inequality that we set earlier, equality has to hold. And the moment when this equality holds is that cos of 5 times each of these angles is really equal to 1. And so that means, for example, therefore 16 cos to the power 5 theta minus 20 cos theta cubed plus 5 cos theta minus 1 is really equal to 0 for theta equals each of A, B, C, D, and E. Then we can try to rewrite this equation in terms of so-called 2 times cos theta. Don't forget about the fact that we're actually doubling the cosine. So first multiply both sides by 2. And we have 2 cos theta all to the power 5. And by multiplying both sides by 2, we have the coefficient here as 32. So that means, which is 2 to the power 5. So I can have 2 cos theta all to the power 5 as the first term. And then we have 5 times 2 cos theta all cubed. I can split it that way because 40 equals 5 times 2 cubed. Plus 5 times 2 cos theta. And finally minus 2 equals 0. So therefore, noticing that this is just the unknowns, small letters A, B, C, D, and E. So generally speaking, I can say for x equals to any of these unknowns, the equation x to the power 5 minus 5x cubed plus 5x minus 2 equals 0 will also hold. This holds no matter x equals A, B, C, D, or E. But for this quintic equation, we can actually factorize it. If you try putting some numbers inside, you'll notice that if you put x equals 2, then we have the equation to hold as well. So x minus 2 is a factor, and we can further divide. And we have this x to the power 4 plus 2x cubed, and then minus x squared minus 2x plus 1. That really equals 0. Furthermore, I can even factorize the quartic into x squared plus x minus 1 times the same thing. So that means x is either 2 or it satisfies this quadratic equation. And by the quadratic formula, we can say that x is equal to minus 1 plus or minus root 5 over 2 as well. Now from this we know that those unknowns A, B, C, D, and E, they have to be either one of these numbers, either 2, or for this, it's either minus 1 minus root 5 over 2, or it has to be minus 1 plus root 5 over 2. And so we need to take care of also the fact that these unknowns also satisfy the fact that the sum is 0, the sum of cubes is 0, and the sum of the fifth powers is also another integer. So that means these solutions that contains square root of 5, which is an irrational number, they must come in pairs. And so that means I must have 2 pairs of -1 minus root 5, -1 plus root 5, 2 pairs. And the number that's left out has to take the other value, and that's 2. So for this 5 tuple A, B, C, D, E, it has to be these 5 numbers. Of course, you can permute the values, and so there will be multiple solutions, but these 5 numbers must be either one of the numbers inside this bracket. Two pairs of -1 plus or minus root 5 and 2. So this is the final answer to these equations. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.